Supposed to find the vector n, which is the cross product of a, b, so this line here, this vector going across from a to b, and then from a to d. So it's perpendicular to the surface of the solar panels, right? Because that's what a cross product does for us, is it finds a vector that's orthogonal. It makes a right angle with a plane. In this case, the plane is the solar panels. So to do that, we have a few videos on how to find a cross product in the course. You evaluate it by taking each individual component, like the I, the J, and the K, and then multiplying them by a determinant of the matrix that's left over. Actually, an easier way to do that would be just to make the matrix for you. So let's just start with AB. Okay, AB is the vector AB is to go from A to B. So A has the coordinates 8, 0, 0, and B has the coordinates 8, 19, 0. So from A to B, that's 8 minus 8 makes 0. 19 minus 0 makes 19. And then 0 minus 0 makes 0. And then the vector of AD here, starting from A, ending at D, 0 in the x component, 0 minus 8 makes negative 8. 0 minus 0 makes 0, and then 8 minus 0 makes 8. So if we want the cross product, then what we're doing is you take now, but I typed it all out. Hopefully that's okay. So when you're trying to evaluate the cross product, you're taking like the ith component and you're multiplying it by a determinant of the matrix that's made by excluding the top row and the column of I. So 19, 0, 0, 8, determinant of that 2 by 2 matrix. So, in the interest of time, we're just going to kind of go over this part a little quickly in this video, but there are videos elsewhere in the course if you're having trouble with what's going on here. If this looks crazy, just make sure to look up the videos on that involve finding a cross product. Okay, so the determinant of this matrix, 19 times 8 makes 152 minus 0. So that one's all done. Now here, 0 times 8 and 0 times negative 8, it's going to make 0. So this is j times 0. And then 0 times 0 makes 0. Now 19 times negative 8, it's going to make negative 152, but that just makes 152 because you subtract here. I'll do that step out. That's 0 subtracted by negative 152. So that gives us 152 for the ith component, and then 152 for the k component. Oops, I think you can see it right there too. But that's, yeah, right here, 152 for the ith component, then 152 for the k component. So that's the vector that's perpendicular to the surface of the solar panel. So it's going in, it's making a 90-degree angle. It's kind of like going the opposite direction of the plane of the solar panels. So for the next part, they give us this vector s, which directs, it points towards the sun at a particular time of day. So this vector s is pointing towards the sun, and they say the flow of solar energy is 900 times s. So all you have to do to find out what vector f is multiply every component of vector s by 900. Let me see. Oops, there's the answers. In other words, f is 900 over the square root of 3 times, well, not times I, for the ith component, 900 over the square root of 3 for the jth component, etc., etc. So we're supposed to predict the amount of electrical power in the panel that the panel can produce. And they tell us that's just the dot product of f and n. So we're going to take our old, what we just found n to be. It's 152 for the ith component plus 152 for the kth component. And we have to find the dot product with vector f. Here, I'm kind of running out of room. And then it's the same thing. 900 over the square root of 3 for kth component. Let's see. Okay, so the dot product is easier than the cross product, right? Because all you have to do is multiply the coefficients of each component and then add them all up. So, and dot product with f is going to be 152 times 900 over the square root of 3 plus, now there's 0 for j, so we can just forget about that. And then for k, it's just going to be the same thing. Because it's 152 times 900 over the square root of 3. So if we simplify that with our calculator, it's just adding to itself. So I'm going to calculate 152 times 900 over the square root of 3 and then just multiply that by 2. Oh, wait, square root of 3. I should have done that first. Okay. Okay, so it looks like for the answer for part B, in watts, because I think we were already in watts, yeah, 157,963. Yep, and then it wants to the second decimal place, so 0.03 there. For the final part, determine the angle of elevation of the sun above the solar panel. Express the answer in degrees, round to the nearest whole number. The angle, here, I might have to draw a picture. The angle of elevation of the sun above the solar panel. So we got the sun. Here, let's just draw that up here. The sun is up here. The angle of elevation of the sun above the solar panel. I mean, the sun is always above the solar panel, but do they mean for the angle of elevation, do they mean the angle between the orthogonal angle, the angle N that we found in the sun? It says the angle between vectors N and S, the angle of elevation are complementary. Okay, so I guess that is what they mean. We got this orthogonal angle, and they're talking about the angle with the sun. I think I should have drawn the sun over here, though. So we have to find the angle between vectors N and S, and then relations complementary. So we'll just subtract whatever angle we get from 90 degrees. So we have this fact that the cross product of u and v, the magnitude of that cross product is equal to the magnitude of u times the magnitude of v times sine of some angle theta, where u, it could be n in our case, and v could be s. So we don't have that cross product. That's something we're going to have to calculate. So here, I guess I'll pause the video and I'll try to type up that calculation. The cross product of u and v would be, actually in this case, n and s would be. So this is the cross product calculation. And then once you have that, then you need the magnitude. Magnitude's nice and quick. It's just each component being squared, and then you take the square root. So like this first one is, we have 152 over the square root of 3 for the first component, and then this is 0 for the second component, because those are just going to cancel out when you do 152 over the square root of 3, subtract by 152 over the square root of 3. And then we've got another 152 over the square root of 3 for the final component. And so the magnitude would just be where you square each element, square each component, and then take the square root of their sum. So here's the square root of 3. Then we do 152 divided by the square root of 3. And then we have to square that, and then add it to itself. So I'm just going to times 2. Because all I'm doing right now is I'm calculating the cross product of u and v. And then we need to take a square root. So The cross product of u and v gives us 124.107. Let's write that down. Eventually we're going to round to the nearest integer, so having all the decimals isn't super important. Now the magnitude of u, in our case we're saying u was n. That's 152 squared plus 152 squared, and the square root. So that's the magnitude of n times the magnitude of s. So that's 1 divided by the square root of 3. That's we need to square each component, multiply by 3, so that's just 1. And then it's times sine theta. So we're almost ready to find that angle. Solve that equation, just divide 124.107 by 214.96, and then use arc sine. So I got an angle of 35 degrees, and the hint we were given was that it's the complement. So 54 degrees looks like, 55 when we round. Okay, I did kind of gloss over these steps. Just make sure if you had trouble with the cross product of u and v, go back and check out that video. If you have trouble with magnitudes, there's plenty of videos about finding magnitudes of vectors too.